Hi, this is Alex from devstories.eu. Snowflake and Snowpark Python, Episode 5 of 17. If you instantiate a data frame representing a billion rows, how much memory does it use on your laptop? Almost zero. The reason why comes down to the core mechanics of constructing Snowpark data frames. A Snowpark data frame is not a container holding your information. It is simply a logical reference to data that resides inside Snowflake. When you define a data frame in your Python code, you are constructing a query plan. This relies on a concept called lazy evaluation. Under lazy evaluation, Snowpark delays executing the underlying SQL until you explicitly trigger an action that requires a final result. Until that trigger happens, every data frame you build is just a lightweight set of instructions. The primary way to start building these instructions is the session.table method. You pass the name of an existing Snowflake table or view as a string. You can provide just the table name or a fully qualified name including the database and schema. A frequent mistake new users make is assuming that calling session.table downloads the table contents into their local Python environment, similar to how Pandas operates. It does not. If you point session.table at a 10 terabyte transaction log, the DataFrame object returns in milliseconds. No data travels over the network. The DataFrame object just registers that specific table as the root node of your execution plan. Another approach is the session.sql method. You use this when you want to define a data frame using a raw SQL string. This is particularly useful if you have an existing query you want to port over, or if you prefer to express a specific initial extraction in SQL. Just like the table method, passing a query into session.sql does not send the query to Snowflake for immediate execution. It creates a data frame that represents the output of that specific query. You can think of it as defining an inline view. The third mechanism is the session.createDataFrame method. This one operates differently because it starts with data already sitting on your local machine. You can pass a Python list, a dictionary, or a Pandas data frame into this method. When executed, Snowpark takes that local data, uploads it to Snowflake, and places it inside a temporary table. The method then returns a Snowpark data frame pointing to that new temporary table. Here is the key insight. Because session.createDataFrame physically moves data from your machine to Snowflake, its performance depends entirely on the size of your local dataset and your network connection. You use this for pushing small lookup tables or configuration parameters into Snowflake so they can interact with your larger datasets. You can let Snowpark infer the column names and data types from your local objects, or you can explicitly define a schema using a Snowpark struct type object to ensure precision. Every time you construct a Snowpark data frame, regardless of the method, you are defining a relationship to data rather than retrieving the data itself. That's all for this one. Thanks for listening, and keep building.